Okay, super geeky C-47 liquidometer video. If you've ever wondered how the inner workings of the liquidometer work, well, here you go. So what we've got set up is a circuit over here. It's this little guy. It's just pretty simple. It's a transistor, a variable resistor, and that's about it, being fed by a variable voltage control signal from 0 to 5 volts. We can vary that with this pot right here. So we're at 0 volts now, which is on the bottom of the scale. About 1 volt is empty. We're going to use that for calibration. And then we can bring it up all the way to full. And there we are, just about at the top of the range. And if you look here, what's going on inside this thing is normally in the C-47, you have a fuel float that's a variable resistance float. And so as 28 volts flows through the thing, that resistance causes that internal element that you can see there to bend slightly. And it's a real small amount of current. It's a less than a milliamp. It's actually 1 or 2 milliamps basically is what causes it. Obviously you don't want a lot of current flowing through anything electronic that's near fuel, so a couple of milliamps isn't going to spark, it's not going to start a fire, and that's why they use that low current system. But what we'll do is we're going to ramp it up from 0 milliamps. We don't have a resistor, so we use what's called a current sink, where we control current, a fixed current from 0 to about 2 milliamps through any load. And so that's what we're seeing here. So I'm going to run up our current. We're at about 1 milliamp here. And as we get higher, we get to about 2 milliamps, that's about full scale range. So that's simulating what that float would be doing in the airplane, but we're doing it with a small circuit that we can control with our microcontroller. And as we bring it down, we'll see the inner workings here. Couple of things I learned about the C-47 fuel gauge. One, don't trust it. If you look here, I'll point it out with my screwdriver, this little bottom element, this little counterweight, that really has a lot to do with where this needle will float. If you bend it toward the instrument, the needle will start to float, bounce between 0 to 25 gallons, and it'll just bounce there. So it's pretty finicky. It's pretty sensitive to anything, any kind of bend, any kind of really anything. Pretty intricate piece of electronics in there. Hard to believe that they built this in the 30s and 40s, but pretty amazing piece of technology for that time, and pretty neat that we're able to take a look at how it's working and hook it up to a modern computer even today. So this will be going in the sim. We're going to be having a microcontroller fabricated for it. We're going to have a PC board of that little circuit, 4 times that, and we'll be driving that with outputs from our Arduinos and driven by the sim. And so this physical fuel gauge will reflect how much fuel is in our simulated aircraft fuel tank. A lot of nerddom here. Hope you enjoyed it, and we'll catch you on the next video.